Hello class, welcome to the lessons on 2.3 and 2.4. 2.3 drawing graphs of functions and 2.4 the domain and range of a function. 2.3 is extremely simple. We're not gonna yet analyze in detail the graphs of functions. So just understand these very few ideas that I'm gonna tell you about and that's about it. It's only 3 slides. Only 3 slides for 2.3. That's about it. It's going to be very simple at this point. So the main thing I want to tell you about is this guys, the difference between the commands draw and sketch according to the IB. These two words, even though they might, I don't know, they may seem the same, they're not in the context of the IB. Drawing a graph means the following. It's a proper, precise graph of a function, and it must have the following features. It must have labels for the axis. It must be drawn with ruler, like the lines that you make have to be straight. All the essential features shown, all the essential features of what? Of the function that you are drawing. They have to be shown, and some points have to be plotted. And basically the main idea is that the whole drawing has to be very precise. And the concept behind sketch is basically the following. It's just a quick drawing showing, please don't confuse this with this. Okay, in what I mean by this, it's a diagram or something. A quick diagram or drawing showing only the essential characteristics and behavior of a function, and it must have labels for the axis, just as before. The labels must always be there. Las etiquetas de los ejes. B. The essential features of a function, such as intercepts and the general behavior. With time, as we go on into our study of functions, you will understand what I mean by this general behavior. Okay, so for the moment, don't worry too much. And C, the sketch or this drawing, the drawing pertaining to the sketch, does not need to be very precise. Maybe I should be very clear here. The sketch does not need to be very precise. It just have to give the general idea of the function. Okay, that's all, guys. Let me give you 2 examples. Suppose that I tell you draw and sketch the graphs of the following functions. This is the first function I'm giving you. F of x equals x squared minus 4. This function. Okay, so this is the drawing. This is the drawing of this function. As you can see, it's very detailed. You see, everything is correctly drawn with rulers, at right angles. The graph itself, it's drawn with a lot of precision. You see, here we can see the intercepts. These are the x-intercepts. This is the y-intercept. And we have some other points, as we can see here. Some other points are plotted, as you can see, like, for example, this point. You see, it's a very precise drawing. Think of a drawing created by a computer, basically. These are the labels, x and f of x. Never miss the labels. And this is what the drawing means, guys. It's something that probably can take you about, 5 minutes to complete. And this is the sketch. Compare both. Okay, as you can see, the sketch doesn't need any ruler. I just go like, there you go, and then I look at the function, and if I know how to analyze this function, I can get the x-intercepts pretty quickly, and the y-intercept, I put them, and since I know that this is a parabola, then I just go like this very quickly, and that's it, guys. That's it. These are the labels. Never forget the labels in any graph, guys. If you forget about this and this thing, the graph is wrong. So that's it, guys. That's it. Compare this. which only gives you the general rough idea of this function, and this is compared with its proper drawing. So this is the idea behind draw or drawing and the sketch of the graph of a function. This takes you about, I don't know, 4, 5, 6 minutes to do it really well. And this takes you about 20 seconds if you know what you're doing. If you know how this function behaves, this takes you 20 or 30 seconds. It's pretty simple. Another function, f of x equals x plus 3. This function represents a straight line geometrically. This is the drawing. As you can see, all the lines are perfectly straight. The labels, we mark the numbers on the x-axis and on the y-axis, 5, 10, and all the in-betweens, as you can see. And these are the interceptions, as you can see. This is the y-intercept. This is the x-intercept. So everything is carefully done, very carefully done. Think of something done through software. And this is just a sketch. As you can see, I go like, there you go, there you go. I put the two intercepts, and I just draw the line going through those intercepts, and I'm done. I just want to give the general idea behind this function. Basically, when I do this, I'm telling the reader, you know what, this function represents a straight line whose intercepts are this and this, and that's it. That's it. No need for pretty drawings or anything. This is the sketch. And that's about it, guys. For the moment, that's all you need to know. That's all you need to know of 2.3. We're gonna get into this topic in more detail in the next classes, but for the moment and previously for the exam, this is basically all you need to know. (2.4) The domain and the range of a function. Same thing, I'm gonna first make a disclaimer, guys. I don't want you to look at this word yet. I mean, not really. We're in the exam. I will not test you on range, not on range, only on domain so far for the exam. Okay, so don't worry about the range at this moment. So what is a domain and range? Let me first ask you a question. If I give you these two functions, and if I ask you, what are all the possible values of the input we can give to these functions? These are functions, as you know, they are machines. They take inputs and then they output something in return. But you cannot, in general, guys, you cannot give any value you want to the input. Not always, not all the time. Let's discuss that idea. Look at this function. F of x equals x squared plus 1. If you notice, guys, we can give the input variable, which is x, any value. F of 1 is going to be 1 squared plus 1. That's going to be 2. I can give the value of 0 to x if I want. It's going to be this. I can give minus 2. That's going to be the following. Minus 2 to the square plus 1. That's going to be 5. I can give fractions, anything, and nothing weird. Nothing weird will happen if I give any value to my input variable in this function. Nothing weird. And by weird I mean nothing mathematically unaccepted or nothing mathematically undefined. So this function is okay with any value of the input, and so we say that the domain is all real numbers. All real numbers. And what that means is that I can give x any value I please, anything, and the function will give me something in return. Okay, if you think, once again, if you think of f as a function, if you think of f as a machine, you can input any value in here, and this machine will always be able to provide an output. It will never break. Never. For any input, it will never break. It's going to be able to process that input and give you an output. Now let's compare this one with this one. G of x equals the square root of x. Let's see. Let me try g of 1. That's going to be the square root of 1, which is going to be 1. Let me give this 1/4. G of 1/4, that's going to be the square root of 1/4. And if you do the math, you're going to get 1/2. G of 0, that's going to be the square root of 0, no problem. The answer is going to be 0. And so on. For any positive value that I give to this thing, everything is going to be fine. For any possible value that I put right there in between the parentheses, nothing weird will happen. The problem occurs when I give a negative value right there, because what I'm going to be getting is this, the square root of -1. And as we know, at this moment in your mathematical development, we don't understand what something like this means. I mean, yeah, in upper classes or mathematical levels, you can define the symbol, but at this moment, since we are working with real numbers only, this is the set of numbers that we use in high school, this has no meaning, because we cannot find any real number whose square root is -1. Okay, I'm sorry, no, we cannot find any real number whose square is -1, which is the definition of the square root, right? The square root of -1 should be a specific number, a number such that when you square this number, you should get -1, the thing in the radical. And that's not going to be possible for real numbers. Okay, so once again, go back to the interpretation of machine for G. When you give G any negative value, -1 or -5 or -3/4, -1.2, whatever, I don't care, any negative value, this thing is gonna break. Okay, and it's not gonna be able to process that information. And so we say that the domain of G, of this particular function, is equal to all positive real numbers and also 0. You see, that's it. That's the domain of G, because this is the set of all the numbers that I can put inside this function, and the function will be able to work it out, to give me an output. If I give any positive number or 0, G works fine, but nothing beyond that. You see? So this is kind of restrictive. When I say this, all positive real numbers and also 0, I am ignoring or rejecting any negative value. So that's the domain. It's all the admissible numbers that I can give to the function without the function breaking, so to speak. Let's continue. Now some terminology. Let's define precisely the idea behind the domain of a function and the range of a function. Even though I told you that you should not worry about range so much at this point, I wanna specify the definition right away. So what is the domain of a function? It's the following. It is the set of all the admissible values, the input variable, that is x, can have in the function. All the admissible values of the input. And the range of a function is this. It's a little harder to understand. It is the set of all the outputs, and as we know, we call the output usually y or f of x, that correspond to the values of the domain. So I'm giving you the definition right now of range, but once again, I repeat for the third or fourth time, don't worry about the range at this moment. Don't worry. We're gonna understand this when we come back from exams. Let's keep on reading. The domain and range of a function are sets of numbers, right? And these sets of numbers are often written in interval notation. Interval notation. So first, what is an interval? Definition. Interval, just a set of numbers. That's it, guys. Interval, a set of numbers. That's about it. That's about it. Let me tell you about some notation of intervals. The notation of intervals is the following. Take a look at this. I want you to take a look at that. Okay, look at these things. This means exactly this. That's what the equal sign is for, right? This is the same as this, and so on. So let me tell you what these things mean, guys. When you see something like this in mathematics, in the context of intervals, I should add, in the context of intervals, this symbol means all numbers between A and B, including A and B. That's all it means, guys, in words. When you see the symbol represents a set of numbers. What numbers? All numbers between A and B, including A and B. That's the reason for this square bracket. Okay. If you go to the real line, the geometrical interpretation of this thing would be all of these numbers, guys. If this is number A on your real line and this is number B, then this thing, means all this collection of numbers, all the numbers that are in between these two square brackets, including A and B. We have to include them. That's what the square bracket means. Now, what about this symbology? It's the same for A, like square bracket A, comma, B, and then parentheses. What that means is the following, guys. It's all the numbers X that are greater or equal than A, but strictly less than B. And the only difference with respect to the previous one is the following. It is basically the same thing, guys. It's all these numbers in this region, in this zone, all these numbers in here that I'm highlighting, all these numbers. The only difference is that we are gonna ignore B. We're gonna exclude B from this set. Any number less than B is gonna be fine, but B itself is not included in here. B is kind of like the limit, and we do not include it. When we use parentheses, we do not include that precise number. For example, let me give you an example. The interval from 1 including to 2 excluding, like this. What does this mean? Well, it means all the numbers that are greater or equal than 1, but strictly less than 2. Let me give you some examples. For example, the number 1 belongs in this set. The number 1.1, the number 1.01 is also inside this set. The number 1.9 is inside here. The number 1.99, which is slightly less than 2, so it's included here. The number 1.9999999 is also here because this number is less than 2. But the number 2 itself is excluded. That's what this means. This number, the number 2, is not within this interval. That's what this means. That's what the parenthesis means. Exclude, include. Exclude this number, include this number. That's all, guys. And the same for 3 and 4. As you can see, number 3 excludes the first number, but not the second. And number 4 excludes both numbers. Okay? and these are another ways to see these symbols, and these are in geometric terms. Let me erase this. In geometric terms, this is what they mean, right? All the numbers from A to B, excluding A and B. And also another important thing that I forgot to put in here, we go strictly from the least number to the greatest number. Okay, always we go from left to right in the real line. Okay, from the left number to the right number in this notation. That's how it works. We're gonna have time to work this out in several examples, so let's do it. Okay, so now we're gonna get some domains for these 7 functions, and the two most basic precautions we have to address when finding the domain of a function are the following. Number one, do not input values into a function that will cause negative numbers into radicals of even degree. Okay, I will explain what this means with these examples. And the same for the second one. Do not input values into a function that will cause divisions over 0. So let's get started, guys. 7 examples. Here we go. Number 1, f of x equals x plus 1. Let's get the domain only, not the range. Remember, don't care about the range for the moment, just the domain. So this is my function, f of x equals x plus 1. And as you can perhaps guess by now, is that we can give this function any value and nothing weird will happen. Any number that we input into this function will have a respective output. So this kind of function has no problems with its domain, and we say that the domain of f, the domain is equal to all real numbers, all of them. Like if this is the real line, all the numbers from minus infinity to plus infinity, this has no problems with any number. Another way we can write this is the following: the domain of f equals the symbol which represents the real numbers. This and this mean the same, so use whichever you like, doesn't matter. You know, the reason I write these guys in pure words is because I want you to understand that you can actually write sentences and words in mathematics. People think that mathematics is pure symbols and stuff. No, you can do this. It's perfectly okay. I mean, I should have written the domain of f equals all the real numbers. This is perfectly okay. This is better because it's more economical, but it's the same idea. What about g of x? G of x equals 1 minus x squared. So once again, for this function, we won't have any problem when we input any value in there. Any number will give me a, let's say, a calculable, no, un número calculable. If I input anything here, I'm gonna be able to get an output without any problem. G of 1/2 is gonna be equal to this, which is gonna be equal to 3/4, etc. Okay, try to give this thing more values for the input, negative, fractions, positive, whatever. I don't care, whatever you like, guys. And this function will always be able to give you an output, always. So what do we say? We say that the domain of G, once again, is all the real numbers, all of them, without any exception. It's a very nice and well-behaved function. So those are the easy cases, right? When we have no problems. So what am I talking about when I say these two things? Well, let's see. Number 3, h of x equals the square root of x plus 2. This is my function. Let's try some things out some inputs. H of 1, that's going to be equal to the square root of 1 plus 2, and that's going to be equal to the square root of 3. I'm not gonna calculate this in decimals. I'm just going to keep it like that. It's a perfectly good output. What about H of 0? Well, there's going to be this. It's okay. What about H of minus 1? Well, let's see, that's going to be minus 1 plus 2 equals the square root of 1, which is 1. So far, so good. And let's go towards more negative numbers, guys, and let's see what happens. H of minus 2, that's going to be this, which is going to be equal to the square root of 0, which is 0, also perfectly okay. So for all of these values, 1, 0, minus 1, minus 2, this function h is being able to give me a nice, well-defined output, no problems. The problem starts when you give any value less than minus 2, like if this is the real line, this is 0, this is minus 2, minus 1, 1. Any value, guys, any value to the left of minus 2 will cause problems. Any value, no matter how small. For example, minus 2.01. This value, which is very close, extremely close to minus 2, right? It's almost, by its side, so to speak. This number will cause problems into my function. Why? Because of this. If I give this value, I'm going to be getting this minus 2.01 plus 2. That's going to be equal to minus 0.01. And that's the problem. That's the problem. We encountered a negative number inside a radical of even degree. Even degree. What does that mean? It means the number that the index of the root. In this case, it's the number 2, but as you know, we always ignore it. And that's what I mean by even degree. You cannot calculate this. The square root of this number cannot be calculated in mathematics at this moment. So what do we say? We say that this number should not be part of the domain. We have to exclude this number from the domain of this particular function. You see? And any other number below this one or to the left, like any other number from right here to the left, will cause the same type of problem. Let's give h of minus 3. That's going to be this. That's going to be this. Not calculable. You see? I think you understand the point. So, what is the domain of h? Let's put it here. The domain of h is this. All real numbers less than minus 2. You see, I can say this perfectly okay. All real numbers, no, I'm sorry. I was going the other way around. The domain is all the admissible. So all the admissible values are this. All this in blue. And this is a square bracket because we can also give minus 2 to the function, as you could see. So let's see. The domain of h is all real numbers equal or greater than minus 2. You see, any number that is greater than minus 2 or equal to minus 2 will be part of the domain, because those will be the values that the function h can process in order to give you an output. Now this is too much, right? How can I write this instead of this, all of this phrasing? Well, I can write this. The notation for the intervals is there for a reason. The domain of h is equal to this. You see, all the numbers from minus 2 including and up to plus infinity. When you when you go all the way towards the right, then you have to put infinity. Okay, like all the numbers from -2 including, and all the numbers towards infinity. Any one of those numbers will work just fine. So one domain, another domain, another domain. Let's now do number 4. Let me clean this up a little bit. I'll come back in a second. Okay, let's continue with number 4. Number 4 is t of x equals 1 over x plus 5. This is the function, and we can give a lot of values to x without any problem to this function. We can give negative values, positive values, zeros, 0, etc. The only value of x that will cause problems in this function is this one, -5. Why? Because when you replace it, as you may be guessing, you're gonna get 0 on the denominator, and we cannot divide over 0. And that's the second case, guys. Do not input values of x that will cause divisions by 0. This particular input, this particular value of the input, when you substitute it into the function, it's gonna cause division over 0, and therefore we must exclude, we must reject this from the domain. But any other value, t of 1 will give you a perfectly good number. T of 0 will give you a perfectly good number. Let's try that one out. That's going to be equal to 1 over 0 plus 5, which is 1/5. You get my point, right? Any other value will be fine. The only one that we should reject is -5. So how do we write that? We write that in the following way. Let me write it in here. The domain of t is, once again, I'm going to do it first in words and then with symbology. All real numbers except 0. I'm sorry, except -5. Make a lot of dumb mistakes like that. All real numbers except -5. This is perfectly okay. You can do this. All real numbers except -5. Now let's do that with symbology. Well, let me erase this. All real numbers except -5. And in symbology, that can be done as this. The domain of t is going to be equal to all the real numbers minus the number 5. Like this. It must be within braces, because we are talking about sets. The domain of t is equal to all the real numbers except or minus the number 5. Another way you can say the same with this type of notation is this. The domain of t is equal to all the numbers from -infinity up until 5, excluding, you see, union. I'm going to explain to you this thing in a moment. Union this other interval from 5, excluding, up until positive infinity. This is another way to say exactly this, or the same thing I said in words. Now let me tell you about that symbol that little u that I wrote. It's not really a u. It's not a u. It's the symbol for union. It actually doesn't look like a u. It's more like this. That's the symbol. But I mean, most people draw it like a u. And what this means is this. It's basically a way to add intervals. So you're working with this interval and with this other interval. And if you notice, guys, the only thing we're doing basically is joining two sets by means of this symbol. We are joining. If this is 0, let me put here -5. This first interval, or this first set of numbers, goes from -infinity. It's coming from the left, and it's gonna stop right here, but it's gonna exclude. It's gonna exclude the minus 5. We have to exclude minus 5, remember, from this domain. And then I have to, let's say, add or paste to this portion, this other portion, from 5, excluding up until plus infinity. You see? And if you want to join this interval plus this interval, this is what you do. You don't write plus. You don't write plus. You do this. You write this symbol. Let me give another example of how to use this symbol. What if you have this? This is the real line. This is 0, minus 1, minus 2, 1, 2. And you want to talk about this. Look, the interval from minus infinity up until minus 1, including, okay, this one. How can I represent this in symbology? It's going to be like this. It's going to be from minus infinity up until minus 1, including. This is this. And I want to join this interval with, let's say, the following. All the numbers from 2 excluding up until plus infinity, up until the right. So if I want to talk about this, the addition of this and this, I need to write the following. Union 2 excluding and then positive infinity. So what this means is all the numbers that are within this first interval from minus infinity to minus 1, including or from 2 towards positive infinity. All these numbers, all of these plus all of these. That's what this means, guys. It's a union. That's how it's done. Okay. So we have 1, 2, 3, 4 down. What about number 5? C of x equals 1 over x squared plus 4. Observe this for a moment, guys. Pause the video and try to see if the fact that the x appears in the denominator in this function will cause any trouble. Pause the video and try to come up with an input value that will cause a 0 in the denominator. Pause it. Okay, come back here, and you failed, right? It's not possible. Any value I give to the x, any value, doesn't matter. 0, minus 1, c of minus 2, whatever, will not cause any problem. Why not? Because this denominator, all of this, can never be 0. Never. Because if this is a positive number, then square it and you will get a positive number, and then plus 4, you will get a positive number. Now, if you put in there a negative number, when you square it, you will get a positive number, and plus 4 will get even more positive, so to speak. So for this function, there won't be any problem. So what is the domain? When there are no problems, the domain of your function, the domain of C in this case, is once again all the real numbers. No problems with this. And number 6, m of x equals 4 minus x over x squared plus 2x minus 3x. Let's write it down here like that. Okay. Like this. Okay. And once again, when we have the variable being in a denominator, we have to take this precaution. This one, the first, no, sorry, it's the second one. Do not input values for the variable that will cause divisions over 0. Now, in this case, it's not that simple to see. Like what values of the x will cause all of this to be 0. Okay, all of these to be 0. And one thing you can find that out, guys, like what values of x will cause this denominator to be 0. Well, let's do that. Let's write this down like so. And basically what I have to do is solve this equation. That's all I need. Let's solve it through factorization. This is one very simple. Through factorization, this is going to be x plus 3, x minus 1 equals 0, right? Make sure. And then we can just solve this equation very simply as x equals minus 3 or x equals 1. If x equals minus 3 or x equals 1, then this equation will be 0, or this expression will be 0. And therefore, these are the two numbers that we have to reject. Because when you input any of these two numbers in here, you will get a 0. Don't believe me? Let's do it. Minus 3 to the square plus 2 times minus 3 minus 3. Then we have 9 minus 6 minus 3, which is 0. You see? So this number, minus 3, caused a 0 in the denominator. And x equals 1 will do as well. Okay? So these are the two numbers that you have to reject. Minus 3 and 1. So how do I write that? I do this. The domain of M is equal to all the real numbers except these two guys, except minus 3 and 1, because these two numbers will cause problems in here. And how did I find that out? Basically, I wanna make this equal to 0, and I wanna solve this equation. And the two solutions that I get, which in this case were this and this, minus 3 and 1, those are the values of x that will cause problems, and I have to reject them from the domain. And finally, this one, j of x equals the cubic root of x minus 1. The cubic root of x minus 1. So let me write it down here. Okay, and don't get confused, guys. Do not look at this one. Do not input values that cause negative numbers into radicals of the even degree. And you may be thinking, give me a moment, please. The phone is ringing. Okay, guys. Sorry about that. Yes. So these are the only two precautions that you have to take. Do not input values that cause negative numbers into radicals of even degree. This radical, guys, the degree of this radical is not even, it's odd. We're talking about a cubic root. And when you try to calculate cubic roots of negative numbers, that's perfectly fine. That's perfectly okay. You will be able to calculate this. If you don't believe me, just input the cubic root of any number, minus 1 or I don't know, minus 2.5, any negative number you want, and you will get a number. Okay, the calculator will be able to do this. It's only when you try to do the stuff like this, the square root of minus 1 or the fourth root of minus 8, when you have even degrees for the radicals, these are the ones that cannot be performed yet. But there is no problem with this. Absolutely no problem. You can always calculate the cubic root of minus 1. You can always calculate the fifth root of minus 11, whatever. It doesn't make any difference, okay? So be aware in here, be aware of that fact, and you must realize that then there is no problem with this. There is absolutely no problem with this function. We can give any value of x, and the function j will be able to give me an output, no problem, because this is odd, because the index is odd. So once again, the domain of j is all the real numbers. By the way, this can also be written like this, guys. The domain of J is equal to the interval from minus infinity to infinity, which is all the real line from way to the left to towards the right. All the numbers, all the numbers. Okay, so that settles all the subtopics for the exam, guys. I already gave you the instructions for 2.3 and 2.4. Only study these slides. That's it for 2.3 and 2.4. That's it. You don't really need to study from the book, and I advise you not to do it. For 2.1 and 2.2, yes, I want you to work with the book also. Try to solve those, the examples, etc. that you saw in 2.1 and 2.2. But for 2.3, only my slides. My slides are enough. And that's it, guys. That's it. That covers all the material for the exam. Good luck and have a nice weekend.